Hello and welcome to the lecture. We have so far studied a lot of the features that we found in MATLAB, which are very useful. And although there's still a lot that we didn't cover in MATLAB, we went through the major features that make the software so powerful. We then looked at briefly at Simulink, and saw how Simulink can be used to also simulate systems in a more graphical way, using block diagrams and using the block concepts to put together systems. And the end result is basically that we can do the analysis, we can achieve the same results using MATLAB commands, MATLAB functions, MATLAB scripts, as we do or we may have with Simulink. And although for the case of differential equations, Simulink does a great job in solving those type of problems. So we leave now the area of MATLAB at Simulink, and we move on to a new application, a new piece of software. And in this lecture, we're going to introduce Multisim. We're going to spend couple lectures, 2 or 3 lectures maybe, digging into Multisim and some of its features and what's used for. So let's go and move on to the concept of Simulink. So again, this is an introduction to Multisim. And we're going to briefly look at what Simulink is and what it does. And in essence, as the name implies, Multisim is a simulator for circuit applications. But it goes beyond just simple electrical circuits in a way that you can also simulate and do things with electromechanical systems. It applies not only, or is used for not only analog circuits, but it can also be used for digital circuits. It can be applied for electronic systems, communication systems, and all kinds of electronic applications. This is a very powerful and very useful tool. So Multisim allows the user to observe the circuit behavior before the actual manufacturing, which is, what we imply, that is a simulation tool. And it can really be very helpful because you can actually select the parameters that you're going to use in the system very close to real world parameters. So that's the statement that says, the first statement that says here that the circuit behavior can be observed before actual manufacturing is really true. Because like I said, you can select the parameters to be real close to real world manufacturing. And we'll see that in a minute. It allows to use ideal components to isolate the sign and circuit limitations. So that's another very useful thing, because you can right away use ideal conditions to see how a circuit may behave, especially like when you're solving, analyzing problems, like in homework problems, for instance. When we do homework problems, we normally assume ideal conditions. And so Multisim is a real good tool to help you in under ideal conditions. It also allows you to make measurements that are hard to make in a real circuit because they might damage the circuit, or they're affected by electric noise, or not possible because of a lack of proper measurement equipment. In other words, some of the equipment that can be used to analyze circuits are really expensive. They might not be available to you right away. They might only be available in a lab environment and so forth. But with Multisim, you have all those virtual instruments available, and they're really, really very close to the real world instruments, as you'll see later. So it's a real advantage. So it also allows to perform repeated simulations with parametric values for a component. So you can change the parameters, run simulations as quickly as you make the changes, without having to rearrange circuits or you know or put new components in, because you can make just those changes in the components you have and run the simulations right away. It also allows you to observe temperature dependence of the circuit behavior and observe circuit behavior under parasitic elements due to real components, meaning again that you can apply changes to your devices, to the elements you're using in the circuit, so that you can simulate real world expectations as far as the manufacturing is concerned. So let's take a look. Oops, sorry. Go back. All right, so what you see here is when you first run Simulink, you'll see something that looks like this. Maybe a few changes depending on, on the version that you're using, or how it was used the last time you used it. But in general, this is what you'll see. The main thing here is to recognize that you have a protoboard area, a circuit area, when you can just build your circuits. If you haven't yet taken the lab for circuits, this is a good introduction, because when you build a circuit in the lab environment, you use what is called a protoboard or a breadboard, which simply means that you put your components in the area and you use wires to connect the different components together, including elements like resistors or capacitors and power supplies. So this is the area you use to build those circuits, and it's very close to the actual real world feel, if you will, that you do when you build your circuit. Some of the areas you'll see here are again a component area, and we'll see how this works in a couple of examples coming up. The components area has, as the name implies, components, the different devices you're going to put in your circuits: power supplies, resistors, inductors, later transistors, any elements that you're going to use for any kind of circuits applications. You also have an area here for instruments on the right-hand side, which includes the instruments you're going to use to make measurements. And like I mentioned just a few minutes ago, one of the great advantages of multi-sim is that you can actually simulate these instruments, of course, in a virtual environment, but it's actually very, very close to what you'll see in a real world environment. And we'll see that later. So that's really, really extremely useful. And you also have another important area here, which is this button here, green button, that you can use to run your simulation. And what it means is that once you build your circuit in this area with the components that you grab in from here, and using the instruments on this area to measure whatever component, whatever parameter you want, voltage, current, and so forth, then you're ready to run the simulation and see or look at the measurements you're interested in making. The other areas here that we'll talk about as we move on to the different examples, but the ones, these three areas here are the most important ones at this point. We're going to simulate a circuit that looks like this. We're going to first start with just a simpler circuit than this. And then we'll add another resistor and see. We're going to start with a 2 resistor circuit, and then we're going to add a third resistor and look at 2 examples then to get a good feel for how multisim behaves. You will see something very similar to this. Your own screen may be a little different on some of the components you'll see in the menu here, but I explain that. most of it, you're gonna see a breadboard area, the area where you're gonna build your circuits. We're gonna put the components and run the simulation. And obviously, you're gonna need components, and you're also gonna need instruments to measure voltage, current, and anything else you need to measure. And on this area, you can see on the right-hand side, this vertical area here has the instruments that you can use to measure different things like current, voltage, and so forth. And it can get very sophisticated. There are devices here that can be used for a lot of applications in circuit design, and not only for analog circuits, but also for digital circuits and for other applications, electronics in general. And so, obviously, in this introduction, you're not going to be using all of this instrument, but we're going to be using a few, maybe a couple of them here. But this is where you get the instrument from, and you'll see how that works in a minute. On this side of the screen, you'll see the components, right? Yeah, here I'll show you in a minute how you can start grabbing components from this area and placing them in the area where you build the circuit. And there are also some other things that I'll measure that go along. This menu here and the items you see in the menu can be customized. Circuit.